Good morning, dear students. My name is Ferhan Mazher, and today is 27th of February 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Cambridge O-Levels Physics 5054. Today, we have set our hearts to solve a theory paper. We call it the paper 2. And today, we will solve its section B. We have selected May-June 2016 2-2 paper. This paper belongs from the zone 2, or you can say it belongs from the variant 2. So the section A of this paper I have already solved, and it has been uploaded in my YouTube channel, and you can watch that section A of this paper in the same playlist. So let's start today's paper. This is the section B of this paper. So let's start. So we have here section B of this paper, and you can see answer to questions from this section, answer in the spaces provided. Figure 9.1 is a circuit diagram. So here you have a circuit. This is a battery. Here you have an 18 ohm resistor, and here you have a 30 ohm resistor. The electromotive force EMF of the battery is 12 volt. Explain what is meant by electromotive force. So here's the definition of electromotive force. It's a 2 marks question. You see, the electromotive force can be defined by 2 or 3 ways. One way is the electromotive force can be defined as the amount of electric energy, amount of chemical potential energy, the amount of chemical potential energy converted into electric energy when unit charge flows through the battery. Another way of defining or electromotive force is the amount of work done by the battery to move unit charge in a closed circuit. So let me show you how I have written the answer. Amount of work done by the battery to move unit charge in a closed circuit is called electromotive force of the battery. So this is the definition. You can write this definition in your paper. Okay, so the next question. He says an 18 ohm resistor and a 30 ohm resistor are connected in series with the battery. State the relationship between the current from the battery, the current I1 in the 18 ohm resistor, and the current I2 in the 30 ohm resistor, because all of them, battery, 18 ohm resistor, 30 ohm resistor, they all are connected in series with each other. Because they all are connected in series with each other, so the amount of current which will come out of the battery, the same amount of current will flow through the 18 ohm resistor, the same amount of current will flow through the 30 ohm resistor, and the same amount of current will go back to the battery. So the IB will be equals to the I1 will be equals to the I2. So the current flowing through the, coming out of the battery, the current flowing through the 18 ohm resistor, and the current flowing through the 30 ohm resistor, they all will be same. Then their question is, state an equation that relates the EMF E of the battery, the potential difference V1 across the 18 ohm resistor, and the potential difference V2 across the 30 ohm resistor. So the EMF of this will be equal to the voltage drop here plus the voltage drop here. So the EMF will be equals to the V1 plus V2. So E will be equals to V1 plus V2. So let me show you. So IB will be equals to I1 equals to I2, and the EMF will be equals to V1 plus V2. Okay, so let's move to the next part. Calculate the current in the battery. So current coming from the battery, the method is EMF divided by the equivalent resistance of the circuit. EMF divided by the equivalent resistance of the circuit. The EMF of the battery is 12 volt, and the equivalent resistance of the whole circuit is 18 plus 30 ohm. So this is how you do this numerical. Let me show you. So current from the battery is equal to EMF divided by the R equivalent. So 12 volt divided by 18 plus 30 ohm. So current from the battery will be 12 divided by 48, and that will be 0.25 ampere. So the current coming from the battery is 0.25 ampere. Same current 0.25 ampere is flowing through the 18 ohm resistor, and the same current 0.25 ampere is flowing through the 30 ohm resistor. The next question is calculate the potential. Calculate the potential difference across the 18 ohm resistor. Calculate the potential difference across the 18 ohm resistor. So you know the resistance of this resistor, 18 ohm. You know the current flowing through the resistor, that is 0.25 ampere. And you very easily, by using the equation V equals to IR, you can find out the voltage drop across the 18 ohm resistor. V equals to IR. So V2 will be equals to V1, sorry, equals to I1 multiply R1. So it will be 0.25 into 18, and that will be 4.5. This is 4.5 volt. Then the question is calculate the power produced in the 18 ohm resistor. I know the resistance of that resistor 18 ohm. I know the voltage drop here 4.5 volt. I know the current flowing through it, and that is 0.25 ampere. So very easily I can find out the power produced in that resistor. Power is equals to IV. Power, the formula for the power is IV. So you just have to put the value. That's it. So the power is equals to IV. So 0.25 ampere multiply 4.5 volt, and that will be 1.125 watt. And that will be, when you round it off, it will be 1.1 watt. 1.1 watt is the answer. So question number 9 and its C part. The resistor obeys Ohm's law. State Ohm's law and describe one limitation on this law. The voltage drop across a resistor is directly proportional to the current flowing through the resistor, provided that the physical conditions of the resistor do not change. V equals to IR is its formula. Potential drop across a resistor is directly proportional to the current flowing through the resistor, provided the physical conditions of the resistor do not change. V proportional to I, V equals to IR. The resistors are made from the same material but have different cross-sectional areas and different lengths. State the relation between the resistance R and the length L of a wire of constant cross-sectional area. You see, the relationship between the resistance and the length is directly proportional. So R is directly proportional to L. The resistance R and the cross-sectional area A of a wire of constant length. The relation between the resistance and the cross-sectional area is inversely proportional. So let me show you. Because you know R is equal to rho L by A, so we can say that R is proportional to L. Second part, R is rho L by A, so R is proportional to 1 by A, or you can say R is inversely proportional to A. A resistor is shown in the figure 9.2 and part of the resistor color code is shown in the figure 9.3. So it has 3 color bands on it: first band, second band, third band. The first band always represents a digit, the second band also represents a digit, and the third band always represents the multiplier, 10 raised to power what? That's the multiplier. So the first band, shade the color of the bands on the 30 ohm resistor. 30 ohm is 30 multiplied 10 raised to power 0. 30 means 30 multiplied 10 raised to power 0. The first color represents 3, that's orange. The second color represents 0, that's black. And because I said 30 means 30 into 10 raised to power 0, so the power of the 10 is 0, so the third color is also black. So the first color will be orange, the second color will be black, the third color will be also black. So let me show you. So 30 ohm resistor means 30 multiplied 10 raised to power 0 ohm. So the first color is for 3, orange, 0, black, and 10 raised to power 0. So for this 0, I will write black. So orange, black, black. That is the color coding. So my dear students, we are done with the question number 10. So let's go and start. So my dear students, the marking scheme for the question number 9 is showing up on your screen. What you can do is you can pause the video and take your time, read this marking scheme carefully and compare the answers which I gave with the marking scheme, and also the answers which you write, compare them with the marking scheme. It is a very, very important habit to always check the answers, compare the answers with the marking scheme. I have already checked the answers. They are good. So question number 9, C, D, and E part is also showing up on your screen. Pause the video, take your time, read that the marking scheme very carefully. So the figure 10.1 shows the basic structure of a cathode ray oscilloscope. He says the electrons strike the middle of the screen and a bright spot is produced. So on the figure 10.1, write the names provided, write the names of the parts B, D, C, B, D, E, and F in the spaces provided. State the purpose of the part B and the part D. So that's the question. First of all, we will name these things. The B is an anode at a very high voltage. So this is anode. This is filament. The D is the filament. E is the Y plates. And F is the X plates. So this is how you will so here you can see on your screen, this is anode, this is filament, this is Y plates, and this is X plates. The purpose of the part B and the D, B is basically anode and the D is filament. So part B, which is basically anode, its purpose is anode is a positive electrode and it has a very high voltage, and its basic purpose is the electrons which come out of the filament by the thermonic emission, and they are negatively charged. This anode is positively charged, and it is at very high voltage. So the electrons will have the electrostatic force of attraction between this node and those negative electrons. So the electrons will accelerate. So it basically accelerates the electrons. The purpose of the part B, whose name is filament, its basic purpose is because it is a heated cathode. So when it is heated, the electrons from it come out into the air due to the heat, and we call this process thermonic emission. So the part B is anode is at high voltage. It is positive. It attracts negatively charged electrons, and electrons accelerate. Part D is a filament. When heated, gives out electrons by the process of the thermonic emission. He says, state the useful energy changes that occur as the electrons hit the screen of the CRO. You see, when the electrons will hit the screen of the CRO, the electrons will have kinetic energy, and that will be converted into light energy. In this case, the light energy produced when they hit the screen is useful. The next part is describe what happens inside the CRO to turn the spot into a horizontal line. You see, it's a 2-mark question. You see, for the horizontal movement, we have X plates. So when this plate will become positive and this plate will become negative, the beam of the electron, because electrons are negatively charged, they will be attracted and the spot will move. The electrons will be attracted towards the positive plate, and the electrons will move from right to left on the screen. And when you make the right side of the X plates positive and the other side negative, the beam of the electron will be attracted because electrons are negative. So they will be attracted towards the positive X plate. So the beam of electron will move from left to right. The voltage which you provide to the X plates, it's if you draw the voltage time graph for that voltage which you have provided to the X plates, the shape of the graph will be sawtooth shape. Let me show you my written answers. Kinetic energy is converted into light energy. X plates are provided with the voltage. Voltage time graph is of the sawtooth shape. This moves the electron beam from right to left on the CRO screen. Okay, so let's move to the next part. The microphone is connected to a CRO to display a sound wave. Figure 10.2 shows the trace on the CRO. So this is the trace of that sound. He says the settings on the CRO are Y gain equals to 0.5 volt. Y gain means the scale being used for the Y-axis, and 1 square will represent 0.5 volt. So the time base is 2.0 millisecond per division, and the time base means the scale which is being used for the X-axis. So on the X-axis, horizontally, 1 square represents 2 milliseconds. So the first question is, determine the maximum voltage. So this is the mean value. So you have to check how high it went. So from the mean value, how much high you went up or how low you went from the mean value. So you can see it has moved 2 squares upward on the y-axis from the mean value, from the mean position. So 1 square on the y-axis represents 0.5 volt. So the maximum voltage is 2 multiply 0.5 volt. Why with the 2? Because the amplitude is 2 squares on the y-axis, and 1 square on the y-axis represents 0.5 volt. So the maximum voltage will be 2 multiply 0.5, and that will give you 1 volt. So the maximum voltage is 1 volt. Then the question is the time for one oscillation. The time for one oscillation means the time on the x-axis for one complete wave, but instead of doing directly time for one wave, I will do the time for 3 waves. So here you see 1 wave, 2 wave, 3 wave. To complete 3 waves, it has taken 1, 2, 3, 4. 4 squares on the x-axis has been used to complete 3 waves. So the time for the 3 waves will be 3 multiplied 2 milliseconds. So if you want to find out the time period for the 1 wave, whatever the time you will get, you divide it with the 3. It's a 2 marks numerical. So let me show you. So the maximum voltage will be 2 multiply 0.5 volt, and that will be 1 volt. The time period for the 3 waves will be 4 multiplied 2 milliseconds, and it will be 8 milliseconds. So the time period for 1 wave will be 8 divided by 3, and that will be 2.67 milliseconds. Then their question is find the frequency. Let me show you the question first. Their question is the frequency of the sound wave. If you know the time period of the sound wave very easily, you can find the frequency. The frequency is equal to 1 by t. The frequency is equal to 1 divided by 2.67 expo minus 3 seconds. So it will be 0.37 expo 3 hertz. So it's 370 hertz. 370 hertz. Then he says the settings of the CRO remains the same on the figure 10.2. Sketch the trace of a sound wave with a smaller amplitude and lower frequency. So here on this graph, you have to draw the wave who has the smaller amplitude. So its amplitude from the mean position will be less, and it has a smaller frequency. So the time period will increase. So first the wave was completed in like 1.5 squares on the x-axis. Now it will be completed, let's say, in 2 squares. So let me show you. I have drawn that wave. So my dear students, the blue color graph is basically showing a wave who has less amplitude and whose frequency is less, means that its time period will be more. So on the same display, now less number of the waves will be shown. I have shown it with the blue color. The graph which is represented with the blue color is the one who has less amplitude and has less frequency. So its time period will be larger. So this blue color graph is the basic answer. So we are done with the question number 10. So, okay, so let's go to the marking scheme. So my dear students, the marking scheme for the question number 10 is showing up on your screen. You can pause the video and you can take your time and read the marking scheme carefully. pause the video. This is the B part of the question number 10. The marking scheme of the question number 10, B part, is showing up on your screen. Pause the video and take your time. Read this marking scheme very carefully. Please check the answers which I have given to you. Confirm them from the marking scheme. So the figure 1.11.1 represents the nuclear fusion reaction. In the fusion reaction, smaller nuclei, they come close to each other and they fuse into one another, and they make a single nucleus which is larger, and this and by this process enormous amount of energy is produced. He says at the in this diagram you can see the tritium and the protium. This is deuterium. Okay, the deuterium and the tritium, they come close to each other and they make a nucleus of helium. This process is called nuclear fusion. This is happening on the sun. So question number 11, it's A part. He says, explain what is meant by the isotopes of the hydrogen. Isotopes of the hydrogen means the atoms of the hydrogen which have the same proton numbers in their nucleus, but their nucleon number or their mass number is different from each other. So they have the same number of protons, but their number of nucleons are different from each other. So they are known as the isotopes of the hydrogen. So the atoms of hydrogen who have same proton number but different nucleon number are known as isotopes of each other. Using the figure 11.1, state the number of neutrons in the nucleus of the isotope tritium. So the number of neutrons, there is one proton and the mass number of the nucleon number is 3. So 3 minus 1, 2. So the number of the neutrons will be 2. Then the question is, state the name of the particle A. The particle A is a neutron. The proton number of the particle B. The particle B's proton number will be 2. Then their question is the nucleon number or the mass number of the particle B. The particle B's mass number will be 4. Let me show you the answers. Okay. So the tritium's neutrons will be 2. The particle A is neutron. Protons of the particle B equals to 2, and particle B nucleon number will be 4. He says at a very high temperature is needed to force nuclei together. Explain why. You see, when you bring the two nuclei together, both the nuclei have a positive charge on their nucleus, so they will have a very strong force of repulsion for each other because both the nucleus will be positive. So when you try to bring close to each other, these nucleus will repel each other because they both are charged. They both are charged with the same charge. They have positive charge on them, so they repel each other. So to overcome that repulsion, high temperature is needed, and so the nucleus, both the nuclei, they are given high speed. They are moved at high speed. And then due to the high speed, the high kinetic energy, they overcome the repulsion between each other. That's why we need high temperature. Tritium nucleus and the deuterium nucleus repel each other with a very strong force. To overcome this force of repulsion, very high temperature is needed to give nucleus high speed. So that these atoms, they are moved, the nucleus, they are moved at a high speed, and when they get the high speed, then they have the high temperature, enough temperature to overcome the repulsion between both the nuclei. A star forms from a large cloud of gas and dust in space. Describe what happens as the star forms. You see, this cloud of gas and the dust, they come close to each other, and due to the gravity and the pressure, the molecules, they come close to each other, and their kinetic energy is very high. So those dust particles, due to the very large amount of temperature and the pressure, the nuclear reactions takes place, the process of the fusion starts, and this, due to this, an enormous amount of energy is created, and at the end, you see, the outward and the inward force is balanced, so the stars is formed. So let me read my answer. Stars are formed from massive clouds of dust and gas in space. Gravity pulls the dust and gas together to form a protostar. As the gases come together, they get hot. A star forms when it is hot enough for nuclear reaction, nuclear fusion to start. Equilibrium is established between outward and the inward forces. So when that equilibrium is created between the outward and inward forces, then that star is formed. The isotopes of hydrogen, H13, has a half-life of 12 years. State what is meant by the half-life. Half-life of a radioactive isotope is the average time duration in which half of that isotope will decay. It's a 2 marks definition. So average time duration in which half of a radioactive sample will decay. Remember this definition. This definition has came in the exams many, many, many times. A sample contains 16,000 atoms of the hydrogen 13. Calculate the number of atoms of hydrogen 13 present in the sample after 48 years. You see, the half-life is 12 years. So after 48 years, 48 divided by 12, 4. So it means after 4 half-life, how many atoms are remaining who has not decayed? That's the question. So here we go. So in the half-life is 12 hours. So, and the total time passed is 48 hours, 48 years, I think. So during this duration, how many half-lives have passed? 48 divided by 12, and that will be 4. So after, let me show you. Years. Okay, years. Years is the best. So when first 12 hours pass by, 12 years pass by, sorry, 16,000 divided by 2, and that will be 8,000. Another 12 years will pass, and 8,000 divided by 2, and that will be 4,000. Another 12 years will pass. So 4,000 divided by 2, and that will be 2,000. Another half-life will pass, and the remaining atoms will be 2,000 divided by 2, and that will be 1,000. So after 4 half-lives, each half-life is of 12 years. So after 4 half-lives, 48 years have passed. So a sample which has 16,000 atoms, now only 1,000 atoms will be left. The rest of them have decayed and converted into daughter cells. So this is how you will do this numerical. I hope that you have understood this. So today we have done. So my dear students, today we have completed this chapter. We have done, I said chapter. My dear students, today we have done May, June 2016, 2-2 paper. In this video, in this session, we have done the section B of this paper. In the section B, we have question number 9, 10, and 11. I have tried my best to explain you the concepts of this paper, this section. And if you think that this video is helping you, if you think that this video has helped you to solve this paper, if you think that this video has helped you to improve the concepts, the answering skill of the physics paper, please subscribe my channel. Also share the link of this video on your Facebook account and on your Instagram account and on your Twitter accounts, because that will help me to promote my channel. Also like this video. If you have any kind of comment, please make that comment. Your good comments give me energy and motivation. So I am thankful to God that I am to some help to you and to many other students who, by sitting at their home, by watching the YouTube videos, are able to do past paper practice, and they can prepare physics for their upcoming Cambridge exam. So thank you very much, everybody, once again. Have a good day. God bless you all.